Let's jump back in time to a world before electricity. Back then, horses bridged our distances and steam powered our machines. Then electricity arrived. This general purpose technology became the foundation of modern life. An industrial revolution, and Siemens was there from the very beginning. We scaled electricity, grids, electric trams, telecommunication, power plants, everywhere around the globe. We brought this new world to life. Now, today, another general purpose technology arrived. This time, it is about intelligence, artificial intelligence. And AI will be as transformative as electricity was back then. It may be even more powerful. It will change the way we live and work, the way we produce and consume. It will make entire systems more adaptive, autonomous and efficient. Grids, cities, whole economies. We have entered the industrial AI revolution. And one thing we know for sure, China is the place where a lot of this is happening now and at scale. It is where you, customers and partners, are driving this revolution. Powerful AI models are one thing, but using them, integrating them, applying them to the real-world problems, scaling them into the physical world, that is a completely different story. And this is one of the reasons why we have come together today in Beijing. Siemens is playing a key role in this transformation towards industrial AI, as we did with electricity. Siemens powered the electricity revolution, and Siemens is powering this industrial AI revolution. We are building the industrial AI operating system. So, what exactly is this? How are we doing this? How are we doing this together with you? That's what we will explore today and tomorrow. So, welcome everyone. Huanling, Beijing. Welcome. Thank you for joining us here in this venue and online. It's great to be here in Beijing, where AI meets the real world. So, you might asking, how can my company profit from industrial AI? Our event will give you answers. When AI enters physical systems, it stops being a feature, it becomes a force with real-world impact, a force that transforms how the world operates. So think of industrial AI operating system as an intelligence layer. It connects hardware, software, and data across the industrial value chain. This layer changes how we design, engineer, and operate machines and infrastructure. In manufacturing, industrial AI is increasing productivity. It is improving energy efficiency and helping to build the next generation of data centers or AI factories. In life sciences, it is shortening the time from lab to patients. But bringing AI to the real world, physical world, requires more than better algorithms. In industry, we need AI with 100% reliability. And this is possible with the right technology stack, industrial domain know-how, and of course, with the right partners. So Siemens brings all of this together, and we are making it available for you. Let's take it one by one. First, the technology stack. It is about software, hardware, compute, highly performant compute with GPUs, and it is about one more key ingredient, which is data, the foundation for industrial AI. The first step is to break down data silos. We are currently doing this at Siemens, and our partners are doing this at the same time. 9 of them have already joined us to create an international data alliance. And you might want to be part of that too. Together, we structure the data, we process it, and then we help our customers and partners to make use of it. That's how we turn data into fuel for industrial AI. Data. The next step is software enhanced with AI and accelerated by it. With our software, you can build the most comprehensive digital twin, photorealistic, based on physics and in real time. AI brings these twins to the next level. Digital twins enable faster innovations, continuous optimization, and more resilient, sustainable manufacturing. Here's an example. Foxconn is using our digital twins to design the next generation of data centers, AI factories. They produce only one thing: intelligence. In our software, everything is simulated in advance: power, cooling, peak load, operations, before a single brick is laid in the real world. This is how AI impacts design and engineering. All that available today. Now, coming from design, the next step is going to operations. This is about combining now many digital twins, like musicians in an orchestra. The digital twin of the product, the digital twin of the machine, the digital twin of the factory, they start now to interact. The whole system runs in one realistic simulation. Our customers can optimize all their processes and production virtually. When we combine our digital twins with industrial AI, this new general purpose technology becomes even more powerful. AI accelerates our software so you can simulate, test, refine the system faster and more precisely. Our AI-enabled software can even predict problems in machines before they appear. An industrial AI agent recommends what to do next, how to optimize the efficiency, the speed, the quality. And it doesn't stop there. We have software that allows us to let AI operate machines directly. And all of this is not a vision. Already here, already available. PepsiCo, our pilot customer, has increased efficiency by 20% in a single facility within 3 months. They achieved this by combining multiple digital twins into one integrated system. That's real impact in the real world. This is industrial AI in operation. Now, when we talk about the real world, it also means, of course, hardware. The next element in our technology stack. And I tell you, hardware is more important than ever. We need intelligent hardware that collects useful data directly from the machines at the edge. We bring industrial AI into every device. We bring it right to the production machines themselves. And we do that, for example, or in particular, with this industrial PC. Inside this box, there is a powerful NVIDIA GPU, perfect for complex tasks, for example, in automotive manufacturing. The training of the model, it happens in the cloud, but the intelligence lives here in this box on the shop floor, where it acts in real time. It orchestrates a fleet of industrial controllers. If a machine deviates from its target performance, this IPC detects and automatically adjusts the parameters to keep the machine and the whole system on track. And this is called inferencing. This is when AI works in operation at the edge. Models not only interpret data, but also trigger actions in real time and all the time. In a factory of the car maker Audi, our industrial AI is checking the quality of welding seams, actually 2,000 per minute. For humans, this task is impossible. Now, our AI alerts the experts immediately where they have to improve quality manually. A similar industrial AI application is helping robots in our factory in Chengdu. The task, picking correct parts from a random pile to assemble industrial controllers. Very easy for humans, but really hard for robots. This industrial PC does the trick. Using 3D images, the AI guides and controls the robots to perform the job. So now, we have data, we have software, we have hardware. This is the industrial AI technology stack. But equally important is industrial domain know-how. This is where your knowledge and your expertise matters. You are in the best position to decide which data matters in your respective industry and how to cluster it to decide which AI application makes sense and which decision should rather remain in human hands. At Siemens, our 1,500 AI experts and tens of thousands of engineers, they work across both worlds, the real and the digital world, with deep domain know-how across 30 industrial verticals. 1 out of 3 manufacturing machines worldwide run on a Siemens controller. Approximately 70% of the world's electricity flows through grids planned or optimized using our software. And with our domain know-how, we build dozens of industrial AI co-pilots. The next step, we are developing industrial AI assistants specifically designed to transform industrial engineering from PLC programming to complex hardware configuration. This will significantly reduce engineering time, automate repetitive tasks, minimize errors, and allows engineers to focus on high-value work. What we see here is efficiency gains of up to 40% in the engineering phase. So, tech stack, domain know-how, but to scale industrial AI, we also need strong partnership. And that's why our co-pilots are built on an open and flexible AI architecture. They can use different large language models from partners like Microsoft or AWS. And in China, we are working with partners like Alibaba Cloud to bring these and other capabilities to customers in a scalable and compliant way. Now, you will hear more in a minute, but the more we use industrial AI, the more compute we need. And that means mainly GPU compute. Here, we are working with another partner, NVIDIA. By the way, I highly recommend to visit their booth outside. 3 examples for our collaboration. First, chip design, software. We integrate NVIDIA's tools and GPU, accelerating into our software, speeding up workflows of up to 10 times. The result? Faster chips, better chips. Second, we are accelerating our simulation software with NVIDIA technology and AI, 100,000-fold. Here, you see the simulation of airflow around a new BMW electric vehicle. This reduces the number of wind tunnel tests which are required normally. The result? Fewer vortices, lower energy consumption. And third, AI factories. Together, we built the next generation of data centers. These are the key ingredients for industrial AI. The right technology stack, industry, domain know-how, and the right partners. This is how you bring the real and the digital worlds together. China. China is the place where industrial AI will scale fast. And we want to support you to do this for your designs, for your production, and in your operations. And today, we will show you extensions of our portfolio. 26 new products, developed in China, for China, engineered for scale, coming from our 25,000 colleagues in this country. Thank you, Team Siemens, for your hard work and dedication, and especially in recent years, you definitively went the extra mile. Thank you very much. So many of these new products will be available on the Siemens Xcelerator Marketplace. Easily accessible for small and medium enterprises. And in China, more than 500,000 users are registered on our open digital business platform. Almost 2/3 of the offerings are AI related, and many come from Chinese partners. You see, no one can do this alone. Partnership matters. And I'm very proud to welcome one of our key partners on stage. A company that started in e-commerce and transformed into leading AI and cloud provider. You probably all know who I am talking about. Please welcome on stage the chairman of Alibaba, Shou Tsai.
Thank you.
So, great to have you.
Thank you, Roland. Thank you for having me. I actually want to start by saying 2 thank yous.
So,
Number one, this is the first time you're doing the tech conference in China, and it shows that Siemens is committed to China, not just in terms of the source of customers and market, but also you're looking for inspiration and innovation coming out of China. So thank you for your commitment to Chinese talent and entrepreneurialism.
thank you very much. Thanks goes to my team here.
And the other thank you is, of course, our partnership. You have mentioned it already, and we've had a great working relationship with your team in China. So I wanted to thank the team here and thank you for supporting it. I think we hope to do more in the future.
Thank you. Thank you for the partnership. So this is when 2 strong partners are coming together. And actually, I have an advantage because we had a chance to chat for the last 1.5 hours behind the scene. I could go on and on and on. And we have tried to bring a little bit of that to the stage right now. So let's start. Alibaba is in its own transformation, obviously, just towards a cloud and AI. So what is the strategy behind, and what is the progress you made so far?
Yeah. Well, most of you know Alibaba as an e-commerce company, but we got into the cloud business a very long time ago, almost 17 years ago, when we decided that our e-commerce business was suffering from data explosion because of the data that we come across from transactions, from customers, from their preferences. And we committed to developing our proprietary technology to manage all of that data. And that was what our cloud foundation and system was born. And more recently, as we run the cloud business, you know, increasingly the workflow and the demand is coming from AI. And so we see a lot of potential in the future of AI. And we've designed our cloud infrastructure to be able to handle very complicated AI workloads. And so that's kind of the progression. The strategy, of course, is in the future, everything is going to be driven by AI. You know, I don't need to, you know, tell you how important it is. Yeah. But if you just take a step back and you look at the last 2 months of what's happened with agentic AI, yeah. A large language model used to be an encyclopedia. It's very knowledgeable, it's very smart, but now it's acquired even a higher degree of intelligence in that it can handle an entire task without you going back and forth prompting it. And so the agent can plan, they can reason, they can plan, they also have memory, and that's very, very important. And we've just beginning to see what's happening. And Alibaba is there to support all the companies that want to use AI with our cloud infrastructure.
Right. And we enjoyed already, so our Siemens Xcelerator platform runs on Alibaba Cloud. Right. We have a lot of corporations also. I mean, you're building data centers, obviously AI factories, using also Siemens technology. So we have already a very, very strong relationship. But before I come back to this AI thing, is it fair to say that Alibaba is somehow a data native company because you grew up with data? I mean, data is so relevant. Mm. So, and that's something what you still have in your DNA, in your company, right?
Absolutely. It's a data native, and the basis of our whole cloud technology is about handling data, right. Not just structured data, but also unstructured data. So yeah, in a way, you're right. We're a data native company.
And we talked about that also before. I mean, it's a message to my team. We have to work on how to contextualize data, make more use out of it. That's another area where we'll look into. AI revolution. You just talked about this agents and what happens. And I mean, it's mind-blowing. I mean, it's almost 3 years now when OpenAI was hitting the wall somehow. And there was a step up in recent months even. And we talked about it. Yeah. And you talk about agents. And you had a very good example how to explain what an agent is, what it does. Can you share that with the audience as well?
Yeah, sure. So, you know, I'm not a software engineer myself. Right. So, you know, when this phenomenon of OpenClaw happened, it's an open source framework for agents, I asked one of my colleagues to help me understand it. Yeah. So what he did was he built a set of several agents, and imagine that the task is he's an online influencer trying to talk about online technology, you know, and on Twitter, let's say. And so he built 4 agents. Number one, he built an agent to screen the daily news, to find the latest tech trends. And the second agent will lift out all the information and develop a thesis of the day. And the third agent does the writing, you know, creative writing. And then the fourth agent keeps track, sort of challenges the thesis and rewrite and all of that. So basically, he's created 4 employees, virtual employees. And that all combined into an online KOL for tech blogging, right? So you could basically do that with agents. And what has happened is an agent is basically a knowledge worker. It's a virtual employee. So if you think about it, the world economy is about 110 trillion US dollars, and labor is approximately 60% of that. And roughly our estimate is 2/3 of that labor is white-collar knowledge workers. So you're looking at potentially almost $50 trillion of potential value that could be either disrupted or enhanced
Yes.
by agents. And that's a massive TAM. That is a bigger TAM than any of the other industries combined. And so the implications are huge now with virtual knowledge workers that could basically do anybody's job.
Yeah. And I mean, another example from our own operations, when we talk about an industrial co-pilot, it uses agents too on the shop floor, for example. And when you have a problem on the line, then you have one agent, which is, let's say, the product agent, which knows what the product is, what you produce. Another is the machine agent, which knows exactly what machine is doing. The next one is the real-time data agent, which is collecting all the information, and you get these things together. And then you can have a problem-solving agent which tells you, okay, you have a problem here, here's the recommendation. And then the other thing is the agent is rationalizing, has a memory, but very important, it finally acts on your behalf. So the industrial agent better gets it right.
Yeah, well, I think one of the important things you mentioned is memory. How does the agent have memory? Well, you have to give it access to information, to data.
Yes.
And this is the place where there are some issues, some problems, because we now see agents getting too much data and then they start to act in a very way that's uncontrollable. But that's very important, is to have the access to data, and how do you control that access and make the agent smarter that way. The other thing you mentioned is the idea of a co-pilot. I mean, I think that in the future with very smart agents, they become the main pilot, not the co-pilot.
Exactly. And we were talking about, listen to that, in particular management, about a strategic agent and maybe even an agent which is a CEO agent. So eventually that helps you or replaces you, I don't know.
I don't think they will replace your job, no, because like I said when we were having lunch, the CEO's most scarce resource is bandwidth, is time.
Yes.
And you try to limit the number of your direct reports because you don't want to be overwhelmed with lack of bandwidth. But now with agents, you actually can manage so many more things, and it also frees you to think about strategic issues and things that's about the future of the company. So I think the CEO will always have a job. The job is safe.
I think so too. So we signed an MOU. We want to enhance our partnership, which is already a very good one. I really thank you for that, also to your team. And the next step is that we are bringing now our software portfolio, simulation software and others, on Ali Cloud, which makes that accessible also for small and medium-sized companies. Eventually we have a SaaS model, so you pay as use. And the idea is that you really can have a faster, better access. That's one step. But then you have Qwen. I mean, you have your own model. Maybe you'll talk about that, which is maybe another area where we want to look into.
Yeah. So about 3 years ago, when OpenAI came out with ChatGPT, in fact, several years prior to that, we have already started to develop our own large language model based on the transformer architecture. And since the advent of ChatGPT, we have decided that we want to be a model company as well as providing cloud services generally. And what that means is you have to develop the leading frontier model, and you have to put resources into it. It's a massive amount of cost and commitment and capital involved, but we've very, very committed to do that. And today, if you look at the global market, obviously in the West, in the United States, there's some leading models like Anthropic, OpenAI, Gemini with Google. But in China, hopefully, we're one of the leading models. And the issue here is it iterates so fast, and different competitors can overtake you for a few months, and then you try to catch up to them. And this is kind of a race, a very, very tight race. But what it takes is long-term commitment. The long-term commitment from management to actually keep investing massive amounts of capital in order to keep the leading edge. And, but we've made a long-term commitment, and we've decided to do that because we think in the future, the power of the model and the quality of the model will help us bring more customers to our platform.
Right.
Yeah.
So there's some people saying this is an interesting business because you spent 500 million to stay for 2 weeks at number one, and then another one comes. Well, but that's how it is, and you have a very good one. But we talk also very often about proprietary models and open models. Maybe one thought on this one.
Sure. So Alibaba's Qwen series of model has a proprietary version that you can access through an API. It has over 1 trillion parameters. It's a very large model. But we also open source several different versions. We have open source models for the device, for edge devices that are smaller models. And the reason we take the open source approach is to push adoption. It's not just adoption in China, but also global adoption. So we have now developed a global community of open source developers that come and try to improve our model. The benefit of having open source is that you could take our model and then you deploy on your own infrastructure, and you could do post-training, you can fine-tune and improve the model to your own purposes, all within your own computing environment. So for people that worry about data privacy, security, this is a very good way of setting up, using a large language model. I think over time, the market will shape up so that there are people that want to use the closed source model through our API, but also a large group of customers that use our open source model, but they all want to have compute resources, which they will then procure from us, hopefully, using our cloud service. So that's our strategy.
Right. What you see, by the way, behind is a AI-created picture using Qwen.
Ah.
Yeah. I like that.
That's really great.
I think you guys did it, so it's really cool.
Looks very nice.
And you really nailed it now when you said currently most of the compute of data center AI factories, which are really dedicated to train models, most of that is the compute is used now to train models.
Mm-hmm.
Portion of that goes into inferencing.
Yeah.
This is when the models are really doing their work on the shop floor. Actually, that should reverse as we go forward. But then we talked about this is blur because because we are tuning models now or post-training.
Yeah.
And that's where actually Siemens come in play. We don't build a large language model. That's something what you guys can do better. But we're using models like Qwen in order to really then tune them on industrial specific data, which are different. Many models didn't see these data yet, and these are completely different data. We talk about time series data, which are produced here on the shop floor. We talk about design data, simulation data, design data for our hardware, and anything which is also visual inspection, all that coming together has to be provided to the models in a contextualized manner. This is where data comes into place. You really have to work on your data strategy as well, and then tune the models. That allows then our customers to take these models and make applications for their machines. That's an area where I believe we have a long way to go, but there's already good applications. We see them already, which are showing the power of AI. And I said it's a new force, which happens and goes through all technologies. just one more thought. People are very often saying, I mean, is this a bubble because everybody's building data centers and is training saturating? I mean, once the models see all the available data, is that then over? That's not true, because the models, when they use them, they create data and you can learn from them. So that's another one, right?
That's the thing. You know, what we found is that the more people that use the model, the more the data they generate, and then you can use those data sets to further train the next generation of models to be better. And so people think, you know, a lot of people say, well, you know, once they stop training the models, who else is going to use all the data centers? Well, the training never stops because the model continues to iterate different generations. And it's not just the big model companies. It's not just the OpenAIs, Anthropics, Alibabas of the world that are training the models. It is every single customer, industrial clients, enterprises that want to continuously train their model. And as they run more inference, they're going to collect more data. So they want to further train the model to improve the model performance. So that's a continuous thing. So I think, why do people continue to invest in data center and the hardware infrastructure? It's because they see the future of model development, or the development of intelligence, is a continuous endeavor.
Yeah. So, I mean, we are running out of time. So, actually, our idea is that we want to boost the industrial AI revolution together. I mean, we need partners. We need many partners, but obviously we need a partner which knows how to run cloud services, a partner who builds models. And we are bringing a lot of technology, as I said before, hardware, software, domain know-how, the whole full technology stack, and data. So, what do you see as the next big step if we joined forces? What would be a target be for the next couple of months?
Well, I would say you have so many customers in China in the manufacturing sector. They make things.
Yes.
Alibaba's DNA and our history has been in the software, and you know, shopping is consumer facing, right? And so there's actually a lot of complementary skill sets that could bring us together. I truly believe that when you talk about industrial AI, AI plus manufacturing, China is the best test bed for that. Because China is the largest manufacturing economy in the world. About 30% of the world industrial output is coming from China. That means, where does all that data reside? It's in China. So this is a great area to test, to get access to data, to continuously improve our joint endeavors and our models and all of that. So I'm very excited to work with Siemens continuously and try to make industrial AI a real thing. And so
we have a great market, a huge market, innovative market, fast-moving market, and we have great partners.
Thank you very much.
Joe,
thank you, Roland.
Thank you very much.
I appreciate it.
Thank you. Thank you. So, now, I can't wait to give you a short teaser about our new products developed in China. And as we scale industrial AI, we need more and more intelligence. So we need a resilient data center infrastructure, AI factories that produce this intelligence. And this is about much more than GPU chips. You need power supply, heat management, design and operation software, and much, much more. So we have new products especially designed for AI factories. Many developed in China for China. Let's have a look together with the expert who built them and with his team. Please welcome our technology expert, my colleague, Fan Lei.
Hi, Roland.
So,
nice to meet you.
I'm pretty sure he picked the right one. So,
Yeah, sure,
what do you
of
have
course.
here?
Yeah, this is our new MCCB, multi-case circuit breaker. We call it 3VD. So, I want to introduce more.
Yeah, go.
It's all about HVDC. Yeah, because of the surge in generative AI, the power density of the data center racks is skyrocketing.
Increasing.
Exactly. So the traditional AC architecture requires a lot of AC-DC conversions. That's leading to a lot of energy loss. So the solution is HVDC. That can save the space by 30%, reduce the corporate consumption by 45%, and elevate the energy efficiency from the chip to the rank to the grid. So this is the reason why we developed 3VD, our Siemens first DC-specific multi-case circuit breaker, which for data center HVDC application. Yeah.
So it changed also the architecture, so to speak, of the electrical system, but you also have a chance to install it faster. There's another feature in it, isn't it?
Exactly. You know a lot, you already know a lot. But today I want to share more with all of you. Yeah. It's a compact design with 2-pole, which means much reasonable for DC application if you compare with 3-pole and 4-pole. So then we can get 20% smaller in size, you already mentioned it a little bit, and 30% faster in installation. Then it can support 800-volt applications in data center for DC. So one thing I also want to mention is this is native innovation with more than 10 patent applications. And we start from the project initiation to the product launch. We are 40% fast than before. So the last but not least, in China, for China and beyond. Yeah. So by the way, Roland, I would like to share to you is we already have some use cases and pilot customers. Yeah, they like it very much.
Okay, cool.
Yeah.
So, and you said it has 2 poles only, others have 3 and 4, you don't miss one.
Yeah.
It's all in.
Yeah.
Yeah.
Yeah, basically the tuple already can supply the DC
Exactly.
the system.
So this is the whole package. It's not only the product, but also the great team which developed in record time a new product which goes into AI factories. It changes the way how we electrify them and superior features. I wish you, number one, great thanks to you and your team, and I wish you good luck for the ramp up, not only in China, but also globally. Thank you very much.
Yeah, thank you a lot.
Thank you.
See you.
Thank you. So, we talked about the foundation that power AI. Big breakthroughs in physical AI are currently happening in robotics, particularly, obviously, here in China. And I guess that most of you have seen robots dancing and doing kung fu. And I saw them fighting in boxing gloves a couple of weeks ago during my recent visit to China. That's a lot of fun and absolutely impressive. So far, humanoid robots are at their best when they do repetitive moves. But they are not the most spontaneous fellows. They still struggle when it comes to real-time reactions, when they have to contextualize in unpredictable environments like boxing. But the speed of progress is breathtaking. Put one in a boxing ring today, so I would say I would step in, but in 6 months from now, I better don't. So now, I'm excited to welcome a tech leader whose company builds high-performance humanoid robots, machines that can move and act in the real world. Please welcome the founder and CEO of Unitree Robotics, Wang Xingxing. Great. How are you? So, wait a second. it seems that somehow you have robots in your DNA. Because you developed your first robots in your first year at the university already. And shortly after completing your master, you founded Unitree. I would say this is really fast and passionate about it. So, what passion brought you into robotics?
我其实几岁开始就小时候就非常非常喜欢科技，但是最开始我玩的可能比较简单，主要是一些动手制作，包括一些化学实验，在那个小学、初中、高中就玩的很多。然后机器人真正开始做机器人也是大一的时候，就是09年当开始大一的时候开始做机器人，而且非常非常凑巧。本身我大一寒假做的第一个机器人就是一个小的，大概这么高的一个小的人形机器人。然后本身的话，我觉得当时也是非常非常喜欢，但是当时没有想着说，哎，我要做一家很大的企业，说，哎，我要让机器人真正走进生活。最开始可能小时候，包括我读本科的时候，最主要觉得是机器人非常有趣的一件事情。
So, but that was a time when AI was not developed to the stage which we have right now. Did you have that at that time when you started off? Did you already have an idea what AI can do?
对，这也是非常非常有趣的事情，也在这里分享一下我跟 AI 的一些有趣的过往的故事。事实上，我自己确实非常非常喜欢 AI。当时大概是大二的时候，大概可能是10年和11年的时候，我就非常喜欢 AI， 但是那时候非常非常冷门，真的是非常，大家可以去看一下，10几年以前 AI 是一个低谷期。我当时在图书馆里去找 AI 的书，基本上找不到什么 AI 的书，而且那时候 AI 有好几种 AI。比如说像神经网络，大家现在知道的比较多，包括还有什么遗传算法，什么各种算法都很多。当时我印象非常深刻，我就翻了几本 AI 的书去编程玩一下。那时候我就非常非常喜欢神经网络，现在叫深度学习。但神经网络那是为什么比较喜欢呢？因为他觉得跟人的大脑非常非常相像，所以我都非常相信神经网络是未来的一个发展方向。但是那时候实在是太冷门了，基本上没有什么好的资料。所以那时候在11年和12年，我短时间可能半年和1年着重的学习一下当时的 AI， 但是后来我就没有去太关注 AI 了，就是我觉得这是我过去这一辈子最后悔的一件事情。如果我在11年和12年就着重去研究 AI， 可能我现在的 AI 水平或者我们公司的 AI 水平会比现在好很多。所以后来那时候就是主要还是搞一些机械和传统的一些控制给机器人去做去了。然后，但是在过去这么多年，大家也可以看到，在16年的时候，那个AlphaGo 打败了那个最好的那围棋，包括过去几年 AI 的技术进步非常非常快。像我们公司机器人的行业也一样，我们公司16年刚成立的时候，或者16、17、18年的时候，全世界大家对于机器人领域的 AI， 大家有在研究，但是效果都不是特别理想。实际上，在19年到2022年的时候，像4足机器人，包括一些人形机器人，全世界大家在上面用一些最前沿的深度强化学算法，已经做出了一些成果出来了。但是那时候主要是接近在仿真环境里面，没有真正的把它用到实物机器人里面去。然后当时差不多在19年到2022年，大家陆续的看到了一些，比如说，我们公司的有些机器狗卖给全球的客户以后，大家很多在上面开发一些那个 AI 软件，让机器狗慢慢动起来，是用纯 AI 软件让它动起来的。但是那时候可能在19、20年的效果不是特别好，但是在21年到22年的时候，机器狗的用 AI 去控制机器狗端到端的算法越来越成熟了，就比传统的基于数学的方法更好，而且放映性更强，稳定性也更好，让我真正的感受到了实物机器人 AI 在里面的一个巨大的变化。所以差不多在21年开始，我们公司的机器人基本上全部转向 AI 去控制它。尤其到22年，尤其在23年，我们公司开始做人形机器人。大家可能想象不到，我们公司23年做了第一款的 H1 人形机出来，基本上是完全端到端的 AI 训练，让它走路跑步。而且非常非常有趣的一件事情是这样的，因为那时候用 AI 去控制一台人形机器人，让它走路跑步，在全球在实物机器人上都是非常非常前沿的一件事情。我们公司一开始做的时候，真的效果也非常非常非常糟糕。那个机器人只能在地上爬来爬去，啥都做不了，走路根本走不了，非常非常难看。但是 AI 的神奇和有趣的地方就在这个地方，就是今天可能非常非常差，但突然我改了一个小小的参数，然后我训练了一个晚上，然后到第二天晚上我上班的时候把它放到我的机场上，发现效果非常非常好，就比原本的传统算法要好的非常非常多。然后这是一个阶段性的一个突变，这我觉得是一个在当下以及每个做 AI 的人最有趣的一件事情。可能一开始大家觉得可能训练出来非常非常糟糕，突然有个质的飞跃，或者我改了一个模型结构，或者我加了一些数据，或我改了一个参数，就发生了质的飞跃。我觉得这是每一个做 AI 的人最激动人心或最美妙的地方。
So when you look at your robots, obviously they have a brain which is super important, which makes the robot really differentiates. What else do you believe, or are you investing in where you believe this is the differentiation factor of a robot of yours, of humanoids?
对，目前最近几年大家都非常非常关注，希望把更好的 AI 放到机器人上面去。但现在确实最近几年技术进步还是非常非常快，但也面临了一些挑战。像举个例子，当时刚刚也提到，像我们23年的时候就开始把深度强化学习放到个人形机器人上去走步、跑步，但是在23年或者说20年初，我们基本上机器人还是只能走路或简单跑一下，而且动作的丰富度是比较少的。但是在24年中下旬的时候，我们就实现了让深度强化学习让一个人形机器可以做各种复杂的动作，让它可以差不多可以跳舞了。我采集人的数据，然后给 AI 训练好了以后放到机器人上，我人怎么动，机器人就可以动，然后实现一个基本的跳舞。大概可能在24年中下面的时候，然后在25年，然后我们有更多的进步，就是机器人在可以做更多复杂动作的情况下，它的稳定性更好了。像我们24年去年4月份，我们就发布了人形机器人可以打格斗比赛，让2台机器人可以相互打架。因为像跳舞或者一些别的一些动作，它是没有外部干扰的。你做跳舞动作的时候，它没有人去推你一下或者踢你一下，所以它对稳定性的要求没有那么高。但是去年4月份，然后我们希望机器人能真正的对抗，因为这样非常非常有趣，而且可以验证机器人的稳定性非常非常好。因为我始终相信，让未来的机器人大规模应用和普及的时候，机器人的稳定性它是一个先决必要条件。你机器人的运动的丰富度和运动的稳定性足够高，我才能大规模去普及。如果未来的一台机器人如果连走路或者打一些功夫动作都做不好，那我觉得它是没有大规模推广的价值的。所以说，我们去年4月份和5月份实现了非常非常冲击的训练，而且大家可以关注到，已经差不多快过去1年时间了。全球范围内真正的抗冲击能力对打的这种机器人，基本上就是还是我们公司为主，非常非常多。我们参加有各种比赛，而且如果你去我们一些线下的一些活动，你甚至可以亲手去玩一下我们机器人，你可以机器人控制机器人去对打，或者你可以去打机器人，都是非常非常有趣的一件事情。这也是当下真正的 AI 让机器人的运动能力进一步的提升。然后像我们今年这次的央视春晚，我们的5Bot，然后让它机器人可以更快速走位。就是像我们25年的时候，他可能表演的时候要是慢慢的走过来再去表演或者打功夫，然后我们今年上半年，我们今年年初我们就实现可以快速的走各种队形。这样的话，因为我们希望机器人在表演也好，在工厂里干活的以后，它一定是要快速的走各种路线，从这里走 A 走到 B， 然后去干活，干好活了以后又换到下个地方。我们希望在这种快速的路线的时候，它是比较快的，而不是说我慢慢的走过去再去干活。因为大家也知道，如果在很多些比较赶的时间，比如说让一个机器人去让你搬个东西或者拿个东西，我们希望它是比较快速的去按一定路线去走，而不是说慢慢的去走。所以这个能力也是非常非常强。所以说我觉得当下这个点是非常非常重要的。但是目前也面临了比较大的挑战，就是目前的 AI 对陌生环境的泛用性或者它的成功率还是相对比较低一些。
Right. So, what brings Siemens and Unity together? I mean, number one is when Unity is ramping up their manufacturing, these guys need to be manufactured. I mean, that's where Siemens comes into play. We know how to manufacture anything, also robots, and automate it. That's a big one. But we are also using Unity robots on our shop floor. So, what you see an example out there is in our booth, you see we are running we have a software called C-Move. It moves AGVs around the shop floor. And the same software runs on a Unity robot. So they're blending in. And now you have not only AGVs, but also humanoid, which can bring things to the manufacturing side. Here comes my question. Now I want to do this guy a particular task, and I see currently it's you need teleoperations in order to train the robots somehow in the real world. Can I train them also in the digital world? Can I simulate a training and let it go, or do I need always to do really real world training with teleoperations?
对，目前对于机器人的训练，确实主要有仿真环境和实物训练两种方式。然后的话，其实很多情况下，目前像我们公司或者很多业内，大家如果能用仿真环境解决的问题，或者用仿真训练就能解决，我们尽可能还是用仿真训练去解决，因为相对来说速度比较快，成本也比较低，比较可以调整一些参数。像我们目前人形机器人，比如说它做一些走路、跑步，包括打各种功夫动作，基本上是完全仿真环境解决的。就是我可以在仿真环境里一次性训练，比如说就几百万个、几千万个环境，然后让它并行的去训练。这样的话，整个的训练速度是非常非常快的，而且整个的效率也非常高。但是目前的条件下，如果就是做一些操作相关的，比如说我让机器人去拿一个东西，或者说我机器人去一个装配几个零部件，目前在仿真环境确实大家目前做的不太好。大部分情况下，目前全球范围内大家还是靠真人去采集这些数据去做训练，去做这件事情。但是真人去采集这个数据，目前也确实面临很大挑战，因为我们现实生活中那个搭建的环境是有限的，你不可能说我在现实环境里面搭建，比如说1000种环境让去采集，这个搭建的费用或采集成本都太高了。所以说，其实包括我们公司，包括很多业内，大家还是希望哪怕手臂去干活这件事情，也尽可能用仿真去采集更多数据。比如说我仿真里面可以去抓一个东西的时候，我可以随机生成任何东西让去抓，这样的话我的数据的规模可以扩增非常非常多。然后，但是目前我觉得这两条路线都是值得去做的一件事情，因为大家都没有特别收敛，包括还有一些什么触觉的仿真，因为有更好的模拟一个物体去抓这些东西，这也是非常非常重要的一件事，也是当下我觉得最重要的一件事情。我觉得目前对于整个的具身智能或者机器人来说，机器人最大的问题，目前移动和动作大部分问题已经解决掉了，但对于抓取和操作这部分，就是尤其触觉相关的。这个目前没有解决好，这也是直接限制了目前为什么具身智能或者人形机器人不能真正的大规模在工厂里和家庭去部署的关键问题嘛。就它拿东西和操作物体的泛化度不够，就是我如果这个物体我训练过的这个东西我去拿和操作，目前基本上训练的好的话，基本上成功率可以做到100%。但是如果我稍微这个东西换一下，它就成功率下降的非常非常快。所以说我补救这个问题，我们就需要有大量的不同物体的数据去把这个坑给填上去。但这样的话，就是目前训练和数据还没有完全解决好。
Right. And when it comes to simulation in the digital world, that's where Siemens takes place, because we are simulating everything. We are getting better and better. I challenge my team also that we can do much more in simulation. One last word. Give me one feature what your robot cannot do today, but let's say in 6 months from now.
对，我觉得目前当下我们最值得做的一件事情是相对比较快啊。就比如说像我们机器人现在打格斗比赛，它的动作相对还是比较机械和固定，就是我的动作都是提前采集的。就比如说我采集了20几个动作，然后它每次去对打的时候，这20几个动作可以任意组合对打，但它的动作相对是固定的。就比如说我现在是这么出拳，我下个动作如果同一个动作出发，可能动作是一样的，这样非常非常没有挑战，也不有趣。但是我觉得在未来6个月左右，我们就可以实现任意动作的生成。就简单的说，我可能也是一开始采集了几百个动作让 AI 去训练，但训练好了以后，它每个动作可以相互的自由的组合在一起，是非常丝滑的。就是我可能可以这么出拳，我可以下左右上下左右各种动作都能组合在一起。这样的话灵活度非常非常大。这样的话大家可能看上去以后，它的动作就每秒钟或者每天它打的动作是不一样的很多动作。我觉得这可能在6个月左右，我们就可以实现这样的技术。这样的话，我们看到1台、2台机器人相互打的时候，它动作的丰富度是非常非常大的，这样非常非常有观赏性，而且它的也非常好看。另外，这个技术对于未来的工厂和生活中应用也非常非常重要，因 因为我们相信，包括我本人相信，只有当一台机器人它能做各种各样的动作的时候，我们把这些动作组合在一起，再加一个 agent， 比如说语言模型或多模态，让它去调用这些动作，那我就可以让它去干活了。所以动作的丰富程度是非常非常重要的，也是决定一个智能化程度的东西。因为大家也知道，比如说我看一台机器人，我发现它只能做几个固定的动作，那我们就觉得它智能化水平是比较低的。但是如果我们发现一台机器人可以做几百个、几千个，甚至几万个，甚至上亿个不同动作，它可以任意组合做，那么我们就觉得它智能化程度是比较高的，它可以任意的自己决定要做什么动作，这是非常非常关键的。我觉得有可能很大可能在未来6个月左右就可以实现。
This is the reason why I don't go in a boxing ring with all those guys in 6 months from now. Xing, thank you very much, and congratulations to what you achieved. All the best.
Thank you.
Thank you. So Siemens has a lot to offer when it comes to scaling robot production, which brings me to the next innovative product we are launching today. Please welcome on stage our technology expert, Liu Hong.
Hi, Roland.
Hi. So, what do you have here?
Yeah, this is our new released S7-200 Smart G2 PLC.
So remember the name. So what does it do?
Yeah, maybe I directly introduce some highlights
Absolutely.
for this
Kick it off.
S7-200 Smart G2 PLC. Yeah. First, you can see the outlook with totally new design for the new PLC with the slim style. Now it's more smaller, can save a lot of customers' installation base. Inside it, we do a very important innovation that is motion control. Now we can control 8 motors running synchronized, very strong performance. Another important innovation, we breathe the new technology. We integrate an AI tool in the engineer software for smart PLC. With this AI tool, that the customer can automatically learning our smart PLC, get familiar with it, and easily to use it. This AI tool also integrate in our another product we also released today. That is our Smart LAN HMI. This AI tool can help Smart LAN customers to generate Java script to build up their own screen automatically. Very cool functionality. So with all this innovation that we hope we can help our customer to get their target together, like mass produce, like a scaling product. Yeah.
Wow.
Yeah.
So it's not only a PLC which is ramped up, so to speak, in with motion capabilities, but it's also the engineering environment which makes it very easy to use and to adapt on the shop floor.
Yeah, exactly. Yeah.
Yeah. So, any other features which you would like to highlight? And how long did it take you to design it and to make?
Yeah, for the design time, really, I'm really proud of that. For as I mentioned at the beginning, this new product is a totally new design. But from the product define until it release, we only use 9 months. That means we are twice faster than before. So think about the reason behind that. First, I think we fully use the local value chain from the product define, from the R&D, from the manufacturing. It's really accelerate our speed. Yeah? And the second, I need to thank to our Siemens advanced digital software to help us design and simulator. This also give us a faster speed. So currently, if talk Chinese speed, I think we can catch up. I have the confidence, and I hope that we can cooperate together with our customer to get successful in the future.
So you see, this is a combination of a great team.
Yeah.
It is a combination of technology, our own technology, used to design a new product in record time. And of course, it's about the ecosystem, the partners here in China, which helps us producing that. Thank you very much. Congratulations to you and the team. Have a great ramp up, a lot of customers hopefully, and I cannot wait for your next innovation. Thank you very much. Cool.
Thank you.
Excellent. In 2025, we established 2 Siemens Accelerator Innovation Centers, one in Nanjing and one in Chengdu. These 2 factories are world-class production sites. Both have been awarded as global lighthouse factories by the World Economic Forum. The complex in Nanjing was designed, tested, and optimized entirely in the virtual world before a single brick was laid. We used our own technology to make that possible in record time. It is our largest research production center outside Germany for high-performance controls for machine tools, drives, and electric motors. And one of the reasons why we ramped up production here, Chinese companies are producing millions of electric vehicles, and they rely on Siemens technology. But there's another element that is essential for EVs. And I guess you know already what I'm talking about, lithium-ion battery system. This brings me to my next guest. He will tell us more about innovation in batteries. Please welcome on stage the Chief Manufacturing Officer and Co-President of Engineering and R&D of CATL, Professor Ni Jun.
Roland, good to see you.
Hi. Good to have you.
So nice to see you.
So, switching gears, batteries now. You told me, or I know from you, from our discussions we had before, that you are an expert in manufacturing. This is where you grew up. And then you said, this is the most complicated and most complex product to manufacture. So, why?
Yes, I've been in this profession of manufacturing for 40-some years, and longer than some of the people at the age. But I worked in many different sectors, from automotive, from the electronics, even some semiconductor, aerospace. But I never run into a single product. It's so difficult to make. Because most of the product we make, once you produce it, it's fixed like your phone. Once you produce it, ship it, and customer use it. But the battery is a product, it's highly complex. It's not only electrochemistry, it involves the physics, material science, mechanical engineering, electrical engineering, fluid, thermal, all kinds of discipline interact. Any imperfection during the manufacturing or during the design stage could cause catastrophic consequences. And so it has a life. During the production, it's a continuous process because we mix the powders in the slurry, coat it on single foils, and wrap it into a product. In the middle of the production, and suddenly the battery has a life. And so we have to care about the safety, the consistency, and of course, the performance and the service life. And so it's a very dedicated product. In most of the industry, when we talk about the world-class manufacturing, we talk about the Six Sigma. Translate into a common language, that means out of 1 million products, you are allowed to have 2 to 3 non-conforming, but that's already the best in class.
Yeah.
You look at all the products we use today, that's a standard. But in battery industry, that's not nearly enough. We require part per billion, B, start with B. Out of the billion product, you're allowed to have a few non-conforming because the probability of causing a incident is very high if you're not careful. So that's why it's so delicate. There's a famous movie called Tender Loving Care. And I think battery manufacturing requires all 3, tender loving care.
So and it's also about, I mean, this is how I see it. I learned it's 15 or 16 steps to manufacture a battery, but then you have to do that in high speed because you produce millions of those batteries, but then with a super high precision, because, I don't know, a little bit of a deviation causes a short circuit, battery is done.
Right.
So what kind of technology are you using? Are you simulating? Are you using AI technologies?
Yes, this is first of all, just follow your question. The battery manufacturing is such a complex and also such a demanding process. For example, one of the key elements of a battery is the electrode. And for example, we coat down the copper electrode, 5 micron in thickness, 1.5 meters in the width, and traveling at 100 meters per minute. And on that single foil, we have to coat 100 micron of the electrode material. It's wet, and you have to dry it over a 70 meters oven with different air, different temperature control. And you have to control that the density, because that affects the performance of battery to micron precision. So micron, if many people don't know what is a micron, if you pull out your hair, the diameter of your hair is about 100 micron. So the precision required very difficult. So we have to rely on AI, automation. We use a Siemens product, of course. We look at from the design stage, from the engineering phase to run production, and even during the field aftermarket, we rely on a lot of big data, AI models to try to make sure the product leaving our factory is to the highest standard.
So, and this brings us also together. So Siemens is one of the market leaders when it comes to the automation of battery manufacturing, using also a lot of our software, simulation software. These are maybe one of the most complex sites, and as you said before that, it's a bunch of different steps which you have to do using different technologies to make it work. So we talk about the batteries as of today, and obviously innovation doesn't stop here. Give us a little bit of an idea. What's the next innovation? What can batteries do in the next couple of years? Energy density, whatever it is.
Sure. Innovation is in our DNA, because this is a new emerging industry. Probably 20 years ago, people haven't heard about lithium-ion battery. Now everything we touch, anything using electricity, probably have something to do with the lithium-ion battery. So we innovate. And we over the last decade, we probably invested more than $13 billion on R&D. We have over 23,000 people in our research team. So for 2022, we launched the product called the Qilin. It's named as Innovation of the Year by Times Magazine in US. And that battery, give you a single charge, can already deliver 1,000 kilometers driving.
Wow.
And 2023, we launched another product called Shenxing. Basically, that brings the whole industry into the super fast charging era. So we continuously looking into the next generation battery, like a sodium-ion battery, condensed matter battery, or all solid-state battery, and even lithium-air battery that are all in our reserve. So CATL, we actually have a long pipeline, and we invest so much R&D funding to develop a next generation and with the next after that. So for example, last year we launched this sodium-ion battery called the Nextra, and this year you're going to see in scale, large volume in the market. So in a few weeks, in this location, Beijing Automotive Show, I hope many of you will be surprised with what's coming out.
Oh, stay tuned, stay tuned.
Stay tuned.
So many people talk about solid-state batteries, and they can go much higher. But as far as I know, they are also more dangerous. So the problem is, how can you avoid any kind of explosion or whatever? Is that under control?
Yes, actually, I want to make a statement. Basically, in the media, in the general public, people have a hype. People think, well, the current generation lithium-ion battery have so much trouble, and the next generation, this old solid-state battery will solve everything. It's give you more energy density,
Yes.
give you longer range, give you all safety, no fire.
Yes, that's what you're looking for.
But if you think about it, if you put so much energy into a small volume, either it's dead or it could give you some trouble. So for the all solid state, it has its own problem. So I think every technology has its own unique application scenario. For example, sodium-ion battery. People think the energy density is not as high as the lithium-ion battery, but it's a low temperature performance, and for certain application, also the supply, the vast supply of sodium worldwide. So that can reduce the cost of the sodium-ion battery. So we believe that will be the big splash.
So does it mean that currently, I mean, almost all cars are powered with electric cars powered with lithium-ion? Do you believe that the world is bifurcating? That in the future you see different types of batteries in the car?
Yes. We not only actually CATL involved not only in the EV sector, we're also involved in the energy storage sector. For the energy storage sector, also the low, high temperature performance, the life, and for that case, the energy density not as high as EV, it's a mobility, but that's a stationary energy storage. And also we look into the future. We talk about AI. I see in your talk, AI has been mentioned multiple times. But at the end of AI is energy system. If you don't have a sustainable energy solution, AI will be limited because it consumes so much power and energy. And besides, the current energy solution is inadequate to sustain the AIDC because AIDC requires different kinds of power performance.
Right. So CATL is also going global.
Yes.
So you're working internationally. This is also where whenever you sit on Siemens technology, you can bring it, and you want to really have a consistent way of producing. We follow you wherever you are. But what is the strategy then going global?
For CATL's strategy, we believe we only have one Earth. That's our.
We too.
That's our
We
home.
believe that as well.
So we want to bring the innovations not from China to the global stage.
Yes.
At the same time, we want to bring global innovation to China because I think the sustainable future requires all human beings, doesn't matter where you live, to work collectively to bring our innovation, to bring our human intelligence together to solve the global problem. So for that, we actually try to bring the best technology to the global community. For example, up to now, we have already built more than 25 million vehicles carrying CATL battery. Basically, every 3 vehicles, there's one powered by CATL. We call CATL Inside. Not only that, we actually try to, through licensing, royalty, and service, try to help global companies and global regions for them to develop capability to address the e-mobility or green transition. So we try to help. In Germany, for example, we have a wholly owned factory, but only 10% of the employees are sent by China.
Right.
90% are locally trained, locally hired. So we believe every country, every community, they should have this kind of capability to really, for us, a human being, to transition to truly green, sustainable future.
So I can go on, and what you see, what you learn here is, number one is we talk about AI, we talk about digitalization, but hardware is more important than ever. And then we talk about technology and of expertise, domain know-how. This is deep domain know-how on 2 legs in the real world. Professor Niu, thank you very much. Great to have you.
Thank you.
And all the best. All the best.
Thank you.
So CATL is expanding from China to the world. So it matters to the company that they can build with tech that scales globally. So let's take a look at the third new product which we are launching today. Please welcome on stage Yang Chengfan.
Nice to meet you, Roland.
So, good to have you.
Yeah.
So, what do you have here?
Yeah, it's G200 inverter, and first I think your dialogue with Professor Ni is very impressive. We are delighted to support CATL's global expansion, including its global manufacturing footprint in Germany. Nowadays, a growing number of Chinese companies share the same ambition to go global. So I think we are there to precisely meet their needs. In fact, most of our newly launched products already hold international certifications, including Smartec ET200 BLIO, Series Smart Safety Relay, Fire Control Alarm System, and our G200 inverter, and even more. And I think these solutions provide reliability, compliance, and sustainability, which are essential for global growth.
So, now, what G200, this is a simple version now, so it's very easy to remember. So this is an inverter. What does it do for those who are not dealing daily basis with this technology? What does a G200 inverter do?
Yes, thanks, Roland. As we all know, the price competition is fierce.
Okay.
Therefore, G200 family offers diverse and flexible solutions to provide our customers different choices. There is a demand for higher efficiency, so its ultra-compact design helps you save space. You can install more devices in your control cabinets or reduce the cabinet's overall size. Meanwhile, it boasts excellent motor control performance, ensuring production efficiency and product quality. And what's also important is that it's designed with digital native concept. It has reliable communication with Profinet and seamless interaction with PLC and HMI in Siemens' totally integrated portal for engineering. It acts as data collector and information hub. What's even more is that most of our new products can connect easily to IoT platform, laying a solid foundation for AI era.
So now here you see how it comes together. It's connected products, they generate data, but they can also then feed the data to the cloud. We can run AI on it, and they're fully integrated with particular features. So, and you also developed it in record time, I understood?
Yeah, record time.
Which is the Chinese speed, which we have here. So thank you very much to you and your team. Good luck with the launch, and I hope to see more new products next time.
Thank you, Roland.
No pressure.
Thank you.
No pressure. Now, we do need human intelligence to make industrial AI work. We need to combine the real and the digital worlds. And that's why we are all here today at the Siemens RXD Summit in Beijing. The industrial AI revolution has started. Together, we are experimenting, we are building, we are scaling, because this only works with partnerships. And the benefits will be huge. Medicines will reach the market faster. Manufacturing will deliver better quality, become more productive and sustainable. Machines will run more reliably. Supply chains, traffic networks, and power grids will optimize themselves. With industrial AI, we will create real-world impact. We will scale this general-purpose technology as we scaled electricity, together with you, in China and all around the world. Thank you very much.